Okay, so now we're going to talk about the instantaneous rate of change, all right, and how that involves the tangent line. All right, so I love this drawing right here. So, like on this curve, whatever it is, we were wanting to find the slope of that line right there. So, if this is indeed f of x, and they said it is, then we are very interested in finding what f prime of x is. All right. Well, no, no, no. That is incorrect. That is actually incorrect. We're wanting to find f prime at a particular point, not for the whole function, just for a particular point. So we're wanting to know what f prime of a is equal to, since a is the x value at that moment. So this is what we want to know. All right. What in the world is the slope? That's the slope of that line right there that is tangent. And again, I love how it's kind of modeling the behavior of the curve. All right, so at the top of that hill, it would zero out, then it would go down, and it would zero out, and then it would go up. Well, not go down, but it'd be going up that way. And then zero, going down here, zero up, zero down. All right, that's a better way to say it. But the problem is if you use the average rate of change formula on this, you get a 0 over 0. Okay. So that's a big no-no. Okay. So I love this. What she says, moving to plan B. Choose a second point that is extremely close to our point of tangency. All right. And we can call it Q. All right. And then we can algebraically estimate the slope of our tangent line. All we got to do is add a really small amount, call it H, to our point in order to create an arbitrary point Q. And it would give us a secant line. So in this case, we're wanting to know about this line, right? But we're going to use this line to approximate it. Okay, so this is not a tangent. It's a little. In this case, it's a little steeper than the line we're really interested in. The line we're actually interested in is this one right here. So you can see I could approximate the purple slope. All right. So by using this red slope. All right. So on the red one, it would be like the average rate of change. So M is the average rate of change. Okay. But on the purple, the M, the slope, is f prime of A, the instantaneous rate of change. Okay. So that's what we're going to do. So it says use the 2 points there, and then we're going to approximate. So we're going to approximate the purple with the red, and you're like, well, that's not right. It's not the exact same thing. That's true. We'll work on that as we move through this lesson. So here we go. So I'll go ahead and say red, since red is really what we're talking about. So, but I like this. I'm going to say f prime of A is approximately equal to, and you're like, nah, they're different. Yeah, they are, but we can approximate it to the average rate of change from A to A plus H. We're just moving on down the line a little bit. Okay, so we're moving A plus H, and this is not correct. Okay, if that's A, then this new point right here would be A plus H. Okay, I think maybe we were expected to change that in the notes. We moved down the line H. All right, H was actually just how far we moved. Okay, down, further down the number line there. Okay, so and that then created an x value of A plus H because we moved down H, and then that changed the function value to f of A plus H, because all you're doing is taking the x value and substituting it into the function. Okay, so you don't have to worry about that too much. All right, but we do have this now. All right, so our instantaneous rate of change A is about equal to our average rate of change between those 2 points. And here we go. Y2, I'm going with the red, Y2 f of A plus H minus Y1, which is f of A. This is just old school slope. So y2 minus y1, and on the bottom, it would be x2, which is A plus H. And if you'll notice, these kind of match up down here without the function notation, minus A. But that can clean up. So let's do that. So the top can't. Top's got to stay like it is. We'd have to do some work on that. And we're going to, in just a moment, but the bottom would just be how much your X value changed, right? So, and you knew that all along to be H. There we go. So what's the goal here? The goal is to approximate the purple with the red. And we know the red. We've done it before.